what a lot of people like to think of physics, they like to just think of, like E equals mc squared. That's just a famous formula out there. And there's even also like F equals ma. So really, in the end, a lot of people are like, "Oh, physics is just a bunch of formulas." Like it is, but it isn't. It's a little bit more than that. And to be honest, we're gonna just be doing physics one right now. So really, we do not need to know this at all. Really, in the end, we're gonna be focusing more or less on this. But in the end, I don't like this at all. Like it just makes me want to just cringe my teeth. I hate it with a passion. F equals ma. It's just not right. But here, let me just show you in a second. So let me just erase it. So physics 1 is basically F equals ma, but in reality, it should really be written as the sum of the force vectors equals mass times acceleration vector. So it should be really written like this and said like that. But for the most case, a lot of people just say F equals ma. It rolls off the tongue a lot better. And that's the only reason why people say it like that. Really, this is what you're going to be doing. This, in my opinion, is nonsense compared to this. This is what you want to do. So let me just get rid of that. But yeah. So we're going to be focusing mainly on this semester. So, well, I guess your semester. I want to call this a semester. Is a bunch of videos put together. So, but yeah. So physics 1 is just going to be mechanics in the end. So which is just this in the end, really. So mechanics. Mechanics. Really, that is just the combination of statics and dynamics. So, well, it literally is a combination of the two. So really, what statics is basically it just is where something is not moving, or basically it has a constant velocity. In other words, there's in the end, basically your acceleration vector is going to be equal to the zero vector. So if your acceleration is equal to your zero vector in this formula, then really for statics, your formulas are just going to be the sum of forces equals the zero vector. Um, so with dynamics, this is literally just dynamics. This is all of dynamics. And to be honest, I feel like if you know statics well enough, or basically, I want you to get to the point where you know statics well enough that you can just do dynamics right away. I feel like they go hand in hand a lot more, and I hate it with a passion that teachers just and textbooks writers just keep them separate. Yes, civil engineers focus more on statics, but in the end, a lot of civil engineers have to take statics and dynamics. They have to take both those courses. So it's not even separated really. And so I feel like if you can do statics, you can very well just do dynamics as well. It's just all that changes is the acceleration vectors involved. So yeah. And just a note for future videos, if I'm doing a statics problem, I'm going to write an S in the top corner, just to denote that it's a static problem, or I'll write D just to denote that it's a dynamic problem. But I will not spend time separating them, because I feel like that's just very, very bad teaching in my opinion. But yeah, so basically in the end, how the curriculum is going to, for this quote-unquote course, go is I'm going to start off by just doing the background information on how to do a free body diagram problem, and then which is just a FBD problem, like a lot of professors like to say. So I'm going to give you the background information on how to do that, and then I'm just going to go into a couple examples, very particular examples, to be honest, that I just want to show you and basically basically show you the quirks behind these examples, because these examples will show up a lot. You'll definitely get stumped once or twice with them. So yeah, so I'm going to go over some of those examples, and then after that's all said and done, I'm going to go into energy and like momentum, and then so after I've basically gone over all the material that I've wanted to say, I'm going to just do a lot of free body diagram examples at the very end. So I really encourage you just to go from video 1 to like, let's say video 40. I don't think it'll be video 40, but so basically all the way from the beginning of statics all the way to energy, momentum, and then if you get through that and you just don't feel comfortable enough and you're just not confident, or you're just like, I want to go through a billion examples right before my final, it happens, so if you just aren't comfortable at that point, I'll have a bunch of examples at the very end. It won't just be free body diagram examples, it'll be a variety of examples, but I'll for sure emphasize free body diagram examples. So yeah, so that's basically the whole setup of this quote unquote course, But I hope to see you in future videos then, and so just to let you know that the next video then is just gonna be on vectors. So yeah, so I just basically have to just decompose this and then do a couple examples for that for the beginning of this course for part 1 and is what I'd like to call it. So for the next video, we're going to be focusing on just this in the end, vectors in general. So just vectors addition and vectors components. So I hope to see you there then.